Good afternoon, everyone, and welcome to SCI's webinar, which is an introduction to steel piling. This is brought to you by two members of the UK Steel Piling Group, which SCI is happy to support. We have speakers Graham Hall. He's a prior chair of the Steel Piling Group, and he's the managing director of Fussy Piling Limited, who are one of the UK leading steel sheet piling contractors. And our other speaker is Jussila Munian. She's the technical manager of Arcelor Mittel sheet piling, the leading sheet piling manufacturer. So welcome, Jess, welcome, Graham. I'm going to give a couple of words of intro about the Steel Piling Group now. So the Steel Piling Group, it was formed in 1995, and no surprises here, it exists to promote the use of steel piling in the UK, and how we do that through getting the best codes and standards, design guides, and raising awareness of the benefits of steel piling, design, installation. So the place to go to find information about the steel piling is www.steelpilinggroup.org. That is the website where all the information is, and downloads and case studies. There we go. There's a picture of the homepage for you. So I recommend having a look there. Now, on the website, you'll find 6 guidance notes. These are really helpful, practical, down-to-earth guidance notes on topics that are frequently cause for questions. The Steel Piling Group, there are 13 sponsors. They might be plant manufacturers, material suppliers, contractors, and we're grateful for the sponsorship of this group. And I just finish off by showing you a couple of our recent publications. P308, Specifier's Guide to Steel Piling, that's our newest publication last year. And that gives a very broad overview about essential topics to do with steel piling. And broadly speaking, our webinar today will be based on the topics covered in this publication, and you've got a free copy. And the other publication is an earlier one, Durability of Steel Pile, that came out in 2019 and gives the latest understanding and guidance on how to be confident in the durability of steel piling. So that is freely downloadable also from the Steel Piling Group website. Enough of me. Over to our guest speakers, and it will be Jess who starts off for the first half of this webinar. Thank you.
Thank you, Nancy, for the warm welcome. Hi, everyone. As Nancy just mentioned, my name is Jess, and I'll be talking about what we can do to help you today. So a little bit about us. We're Arcelor Mittel, and we've been making sheet piles for a very long time now. And as a company, we make all kinds of steel products. As a team, I'm specific to the sheet piling department. So if we have a look at our topics for today, we'll have a look at what is a steel pile, how we make them, and we'll have a couple of steel grade, how we make those as well, and some connection details. We'll talk about durability as well, and I'll give you some information on some design standards as well. So what is a sheet pile wall? It is simply the vertical interlocking of sheet pile segments. So if we're looking at hot walled sheet piles, these conform to EN 10-48 standards, where the interlocks are the key ones here. Now these are fully formed, so it means that when you connect these piles together, the wall will act as a single unit, such that shear can transfer across the wall. And this is what we define as a structural wall. So at the larger end, we've got marine structures. This would be permanent works such as breakwaters or quay walls. We've also got land-based structures such as bridge abutments, flood defense walls. And we can also see them as temporary structures. So these would be cofferdams that are in land or water. Now, the manufacturing process itself, it's not an easy task, but because of the many processes that the steel has to go through, steel actually gets better with time. So the traditional way of making steel is actually through the blast furnace method. But with this method, temperatures have to stay up all the time, and we also need a lot of resources to make the steel. So in 1997, we shifted to the more efficient electric arc furnace method. Now this method, it uses scrap material, so it makes it a recycling process, and it also uses electricity, so it has much less carbon footprint for the piles. Now, if we have a look at the electric arc furnace method, steel will go into an electric arc furnace, and that we use scrap material, and then through the many processes, it will liquidify the steel, and we pour them into a continuous casting system, where it gets shaped into a beam, and using a water-cooled interior, we cut them into shape. And from the previous slide, I just mentioned that we shape them into beam, and there's two reasons for that. First, it's easy to store them this way. And second, they are ready to get formed into shape. Now, at the rolling mill, the piles will go through 4 different rolling stands. And then the interlocks would be the last one to be formed, which because they are complex and they have to be able to be connecting to other sheet pile sections. So the tolerances are very critical for this to work. And maybe one thing to take from this slides is that all the sheet pile sections from us will be able to connect to each other. So sheet piles are measured through the elastic section modulus per meter run of wall. And the higher the modulus, the stronger the section. If we look at designing the sheet piles, we will have to look at the geotechnical design and also a structural aspect for the sheet piles. If we look at the geotechnical design, usually we'd be looking at the soil properties and the variable relating to the depth of the piles. So these would be the CU value, the phi angle, and so on. And this will then give us a bending moment profile so that we can calculate whether we need a cantilever wall solution or some type of combi wall system for the piles. And the piles, they are named simply based on the shape. If you look at our general catalog, we'll have 4 different pages to give you the sheet pile section. So there's quite a lot to choose from. And if you look at one of the pile itself, let's say, for example, an AZ 26700, A is for Arcelor Mittel, Z is the shape, 26 is actually the key number here. It just means it's a section modulus, which is usually rounded to the nearest 100. And they also give you an indication of the strength of the pile. Now the piles, they come in families of 3 or 4. To give you an example, for an AZ 38700N, we can roll 1 mil thicker and we get a 4700N, and we can also roll 1 mil thinner and we get a 36700N. N is just short for new, it means it's our latest additions. Now we also have U piles, they are quite popular as well. We've got GUs and PUs. Many of these piles are actually the exact same, they simply come from 2 different mills. If you look at the GUs, they come from Poland, and the PUs come from Luxembourg. And we also produce AU piles, which are actually quite more efficient, and they're in production as well. But as it turns out, many contractors still prefer the GUs and the PUs because they have the experience and the equipment to installing those, so they tend to use those a lot. Now, with the interlocks, all of our piles have the Larsen interlocks, which means that they can all be connected together. You can also connect a Z pile to a U pile section, and you can also connect to an existing sheet pile wall if the interlock is free and available to interlock. And if you need tighter corners than 5 degrees, usually at the interlock, we can achieve 5 degree swing. But if you need tighter corners than those, Then we have a couple of corner sections that can help you with those. If you look at the free corners, such as the C14, Omega 18, and Delta 13, these ones, they are mechanical interlocks, which means that you can connect them on a sheet pile interlock, and you can achieve a specific angle deviation as listed here. But if you need something more specific, then we can suggest the C9 section. It's more adaptable. You can weld it at any point on the sheet pile and at any angle, and achieve any tricky angle deviation, say 20 degrees, for instance. And then we've got HB bearing piles as well. So we've made those as well. And you can get dimensions from 200 mil to 400 mil. And you can often find those with wall thicknesses of between 9 and 24. And they're quite useful if you have got a key wall system and things like that. They can be quite useful. Then we got box piles as well, also bearing piles. They can be used, you can weld 2 or more different sections together, and you can make a box piles out of those. And these ones, they can be installed in the ground as open box piles, and then they will, once they have been installed, you can use them as dolphins and things like that, and they are quite useful. And then we've got bearing combi wall systems as well. So the HZM system is quite useful, and these are usually for marine environment. They can be quite useful. And if you look at the H-beam on these piles, they are actually having a much thicker flange than regular H-beams. And we have to mill a groove on the H piles to be able to connect a connector to those. And then we can connect Z piles to those ones. Now, for most of your piles, you'd be looking at EN 10-48 standards. And within the standard, we can go from S240 to S500. But as a company, we've increased our benchmark to S355 or higher, as there's no cost benefit to producing the lower grades anymore. And you'll also notice there's S460 and S500 on this slide. And this has been introduced last year in 2023, September last year. And we have been producing S460 from a while ago, so these are available. And S500, speak to us if you would like to do those as well. We can also make piles to different standards as well. If you're designing to ASTM method, Chinese, Japanese, that's easy to be done as well. Now, of course, there is an optimum solution. If you're designing with sheet piles, say you need a bending moment capacity of around 1500, and you've got 4 different pile sections using 4 different steel grade. Now, as a rule of thumb, always go for the highest steel grade. It's always more efficient, but maybe 2 things that you need to check is that you're not installing something that's too thin, as when you're using a higher steel grade, you're also using a thinner sheet pile section, and maybe also check your durability, because you need to check that you're not installing something that's too thin over the lifetime of your sheet pile. So sheet piles, there's various ways to avoid corrosion, and sheet piles will corrode when in contact with water and oxygen together. So you've got to protect them. And one way to do that is through sacrificial thickness. And if you look at the UK National Annex, it'll give you two tables to account for these losses. And you can also look at some other factors. If you look at a higher steel grade, now this is just protection at the end of life, and it will give you a higher bending moment resistance, but you will still have to use some kind of corrosion protection. For instance, you can also coat the piles, and this is very often done for aesthetic purposes. And you can also use a concrete capping beam. Now, this can sometimes be used at road level, where it serves essentially for 2 purposes. One, it protects against crush, it protects as a crush barrier, or it also protects against salt spray. Now, as I've mentioned before, we've got 2 designs for this, for the sheet piles. So essentially we've got EC7 Part 1. So this would be for the geotechnical design. And then we've also got EC3 Part 5 for the design of steel structures. Now, for most of your projects, you'd be looking at designing for a bending moment resistance to a class 2 or 3. And these equations will help you with those design. But if you're designing to a class 4, local buckling is a possibility. And one other thing, you'll have to do a lot of different calculations and a lot of searches to be able to get the piles to work. And worst thing is sometimes the pile may not work with a class 4. So it could be useful to try and get your steel to a class 2 or a class 3 for this one. Now we've got some durability software. This one is free to download on our website, and you can have a look through those. And to give you an example with this one, you just have to include the steel grade, the sheet pile section that you're using, and then the software itself will calculate the losses for you, and it will give you your results for bending, buckling, and even axial forces, shear resistance as well. This is also one of our softwares, so AM Retain. For most of our projects, we usually use AM Retain, and then we cross-check them with other software packages such as Wallup or Reward. And one thing that this one does over other software packages is that it will calculate for double wall solutions, and it will calculate all the solutions with a subgrade reaction model, and all of those information will be calculated to Eurocodes. So it's quite useful if you want to have a look through that as well. But this one is available on request. It has been developed by Arcelor. Now, when it comes to steel itself, it's fully impermeable. The only way that water can get through is through the interlock. Now, there's various ways that you can seal those. And if you have a water pressure of less than 1 bar, then you can look at something like a Belton Plus or Argo Seal, and it will seal the interlock, make it watertight. And then if you have a water pressure of less than 2 bar, then I suggest you have a look through Proxon Plus. Now, this one is a water swelling product, and it can take up to 2 hours to start swelling up. And if you need something that's higher than that as well, we've got the Akina. This one is useful for water pressures of 100 kPa, and it works as a compressive filler. So it's got like a free lip system, and when these piles are connected, the wall will act in compression, and it will completely make the piles watertight. And if you need that full water tightness, then welding the piles can be an option. You can weld the piles fully. Every double piles, you can weld them fully at the mill. And on site, you can weld at every other interlock down to the formation level. Of course, we've got some literature for you. And this is a list that applies mostly for your design. So we've got EN 10248, EN 10249, and EC3 Part 5 for the design of steel piles. Got EC7 Part 1 for the geotechnical design, and also EN 12063, which is very good for geotechnical design works. And some recommended readings. We've got the Key Wall Handbook, is quite useful for your detailing. Got EAB 2014 for excavation works. We've got EAU 2012 for waterfront structures. Quite a lot of interesting information in these documents. Have a look through those, quite useful. And these have all been translated from German editions. And you can also have a look through the Steel Piling Group, which has a lot of information on detailing case studies as well. And the SCI website will give you a lot of information with the durability software. With the durability, the B22 is quite a useful one to have a look at. So we have, as to conclude, we have seen sheet piles, steel piles as temporary and permanent solutions. We have seen them as combi wall system. We have seen some durability of the steel piles as well, and how sacrificial thickness is one of the most cost-effective solution. We have seen some optimum solution, how you can optimize your sheet piles. And we have also seen some watertight solutions. So this is it from me. I hope this has been useful. And if you do have any questions, I'm sure Nancy can take them and we can have a look through. Thank you.
Thank you, Jess. Having heard about what products are available and how to design them, we're now going to move over to hear a contractor's perspective and to learn more about installation and the extraction of sheet piles. So I'm now going to hand over to Graham Hall of Fussy Piling, who's going to present the second half of the webinar.
Well, good afternoon. As I say, I'm Graham Hall, Managing Director of Fussy Piling and former Chair of the Steel Piling Group. So thank you for attending. So why do we want a sheet pile wall? Sheet piling is a versatile retaining wall system used to cantilever to support ground up to about 4.5 meters comfortably. Above 4.5 meters or adjacent to sensitive structures, deflection can be an issue. And in that situation, such as the example here we have, you can install propping or anchors. However, more important, before we decide whether we want a sheet pile wall, one of the first considerations is what is the ground that the piles are going to be driven into. Very brief example, this was the job up Trafford Walton in Manchester, and they wanted a hole in the ground about 5 meters deep. Just in sheet piles in cantilever. However, part of the issue was effectively, if one looks at the end values of the soils at 4.45, 5.45, effectively it's refused with end values of 50. So what size are sheet piles? As Jess discussed earlier, you need to make sure you've got sufficient room on site, and from the lightest pile sections, the piles are 312 millimeters deep, up to the heaviest U sections at 452. So one needs to allow a 400 to 450 millimeter sheet pile zone in which the piles can be installed. We often see just 100 mil of sheet piling zone because people think of them just in terms of trench sheets rather than heavy duty sheet piles. So in terms of installation methods, there are two basic installation methods. There's a piston drive and panel driving. Now the piston drive installs the piles one by one. This can lead to a bit of forward lean of the piles and some out of tolerance unless you're controlling the verticality as you're driving them. Panel driving, a more traditional technique, is slower and needs more crane maneuvering and involves operatives working at height. So some of the considerations, main considerations, are the soil conditions, the sheet pile sections and length, driving equipment, whether the sheet piles are going to be designed to be permanent or a temporary wall. If the wall is going to be visible, such as this example, so you might want to paint them for aesthetics or a lovely stock rusty colour. And installation tolerances are very, very important in terms of vertical position and alignment. And as Jess discussed earlier, interlock sealant systems can be used to make the piles impermeable. As a reminder, it is possible to drive sheet piles into pretty much any soil type, but the choice of the installation method is key for the panel driving equipment. Additionally, an extensive soil investigation should be completed before the piling method is chosen. My old geotechnics lecturer used to say to me, you pay for you pay for a ground investigation, whether you have one or not. So talking about, say, traditional piling installation methods, still used a lot in the marine environment. This is what we call a Kelly block setup, where you set up a frame and the sheet piles are interlocked into them. These are called piling gates. They're good for ensuring the alignment of longer piles. Now, when one is constructing sheet piles by what's called panel driving, you set up the gates, you install the first 2 piles and drive those down. You then fill the gates up with remaining piles, drive down the last pair of piles to keep the piles straight and plumb, and then you then drive the remaining piles back to the top gate level. You can then shift the gate left or right, depending on the direction of construction. So crane suspended equipment, the traditional stuff, it's used to drive the piles in sequence, but noise and vibration must be considered when using this equipment. Here we can see a piling vibrator hanging off of a traditional lattice screw jib crawler crane. Here is a BSP hammer. Notice the legs extending down, again crane suspended, and the yellow legs extending down beyond the top of the piles to keep the pile driven straight. And again, traditional piling gates in a marine environment with a Dawson hammer there. So starting at the bottom end, really at the lowest level, an excavator mounted vibrator can drive the lightest sheet piles and trench sheets into the ground. The size of the vibrator and excavator must be considered relative to the ground conditions and the type and length of sheet pile to be installed. Okay for driving into granular soils, not very good for driving into cohesive material. You still occasionally, once people have stood piles up with an excavator-mounted machine, you'll still see occasionally an old air hammer being used. The technology is very, very old. It works, but it's still used in some places. But they do create a lot of noise, and you can damage the sheets when you're driving it. Now, excavator-based piling systems, you might know trade names of Movax or Side Grip, or there's Gilbert Grizzly Multi-Grip. The advantage with these sorts of systems are that it does allow you to work on a tight area where width and height can be an issue, and where conventional cranes and drop hammers or whatever is impossible. You can put various attachments on the end of it. So here we've got, in the middle is a Movax. On the left, we've got a pre-auger attachment fitted on there to assist with driving. And you can even put a big drop hammer on the end. What's important with these systems, both as we as a piling contractor and steel piling group, is these systems should be running on a piling mat. You shouldn't just be running them on dirt. These attachments can weigh anything from 4 to 5 tons, swinging around on the end of a 30-ton excavator. Telescopic leader rigs, very versatile rigs. Again, you can change the front end from a city vibrator, a pre-auger, or an impact driver, or even a rig-mounted press. And here's a Bauer RTG thing with showing say vibratory piling on the left, and then on the right some pre-augering, and this is just showing some pre-augering with a nominal 400 diameter auger. With respect to vibratory installation, as a business, we tend to use the Bauer RTG 16T leader rigs. Very fast installation, potentially 750 meters squared of piles installed in a week. We tend to drive piles up to about 14 meters, but hence the name 16T. You can drive a 16-meter sheet. With all these leader rig type systems and modern driving systems, you get low levels of ground-borne vibration and you get some noise. We would tend not to drive piles closer than about 15 meters to a building, but you take each project at its own merits. And again, talking about the versatility of the leader rig, there is what's called a leader rig mounted press, or a hydro press made by friends at ABI. Now, what this does, it grips hold of 4 piles and pushes the piles in individually, and then you lower the 4 piles down. It's very good in soft ground or cohesive material, but not very good in sort of stiff clay. Or gravels, just by the nature of the beast. Some people tend to stand piles up with a minimal vibration, and then they can use this to back drive piles down to level. Another tool in the box is a silent vibration-free installation pile presses called Cohen Steelworker or Geekin type rigs. As a business, we tend to use the Cohen Steelworker WP150. The WP150 has a unique tilt mechanism to ensure, as I mentioned at the beginning, with a pitch and drive method, there's a tendency for the piles to creep forward and lean. So using the tilt, you can ensure that the piles are always going in plumb. Piles generally up to about 18 meters can be driven. We've driven 20 meters. I'm aware of people driving 24-meter long piles with this system. So typically 6 to 14-meter piles is the bread and butter. About 450 square meters of piling in a week. In terms of pressing force, the WP150 will press up to 150 tons on an individual sheet and will pull up to 160 tons to extract a sheet. And it works by sitting on 3 piles to push the next one. But of course, what does that really mean? So as you can see here, you can see 2 machines sat on the piles. I say that so it sits on 3 piles, and it pushes the second pile all the way down. It then lifts itself up on its carriage, moves itself forward, sits itself back down, and then pushes that pile all the way home. And it repeats this over and over again. It's as near to a sort of factory type production method as you're going to get with driving sheet piles. A very, very controlled, safe method. And there's probably 30-35 units currently in the UK pushing piles in. The thing with this method, though, is obviously driving the first 3 piles. Some people use a Movax or piling vibrator to drive the first 3 piles, but you've still got noise and vibration in that scenario. We tend to use a reaction stand, which looks a bit like this in section. This particular stand is slightly elevated because we're putting some dummy piles in to go into a side of a hill. But again, here's some piles down at a reaction stand down at ground level. We tend to put the sheet piles used for the project onto the reaction stand, which is about 50 or 60 tons of kentlage to react against. You use that reaction weight to pull against to install the first 3 piles, and that's a back view of it. In tougher driving conditions, so dense ground or stiff clays, one can use a combination of pre-augering and or water jetting to assist in getting the piles. As I mentioned, the SCI publication 308 gives a lot more detail to it, but you can see on this particular site, this is a job in Southwark where you've got dense gravels overlying London clay, and on this project we pre-augured with a 400 diameter auger at 600 centres all the way around there to facilitate driving the piles. Say other people may well water jet to achieve the same. When you've got really tough ground conditions, you can get a real beast of a machine called the Geekin Super Crush. Now what that does, it uses a rock auger housed inside a casing to penetrate the hard ground. As you advance the pile, the auger removes some of the soil, and it enables silent piling into very hard ground and rock. Production's not rapid with these systems, but it does enable you to get piles into ground that perhaps you wouldn't ordinarily be able to do it. Interestingly, I understand that the minimum pile section for this would be a 7-meter long GU27, which is quite a heavy pile for that length. But you can drive piles in pairs, as Arcelor's heaviest section, the AZ50, up to 24.5 meters with a different type of super crush. But these machines are quite heavy. As I say, the single press weighs 16 tons and the double Z press weighs up to 27 tons. So you do need some serious craneage to be moving this equipment around the site. But in the right ground, in the right conditions, it's a useful tool. Now, once you put all the piles in, sheet piles are very useful as temporary works, and so you often want to pull the piles back out again. So that can be completed with a piling extractor vibrator that can be crane suspended or mounted as a leader rig, or alternatively, which we tend to do, is we use a pile press, and that avoids the need for anybody to working above ground level. It also is obviously a silent and vibration-free method of pulling the piles. Again, with the steel worker It grips on the tops of the piles and takes out each sheet one by one. Now, noise and vibration, as I mentioned previously, is a big consideration when driving sheet piles. Now, this table is taken from the SCI publication 308, and you can see on the right-hand side sort of typical noise levels at 10 meters. Obviously, if you're closer than 10 meters, the noise level can be considerably louder. This also needs to be considered within the context of the site, i.e. if you're working next to a noisy motorway, then will the piling operations be actually greater than the adjacent noise? And vibration, again, a very big hot topic when installing piles. This is an empirical formula that we use to give a bit of a guidance, really. And looking at the graph, you can see at distance, typical vibration levels can be very high close to the piles, but it dissipates very, very rapidly. And again, if vibration is a problem, such as you're working adjacent to a water main, a gas main, or some other sensitive structure or utility, it's always worth getting some background readings before the piling equipment arrives on site, because sometimes you can find the background readings are greater than what the limits you're trying to not exceed. This table here, if you look to the left with the little yellow dots, this is sort of the vibration limits, the peak particle velocities we've got in distance, comparing it with the green, which was when after the ground was pre-augered. So you can see that pre-augering can help reduce the amount of vibration transferring through the soil. There's no black and white answer as to reducing it by a number, but pre-augering can help to reduce vibration on occasions. Again, this is a very brief case study. This was a job in Chester. It was a care home. There was people next door just over the fence that they didn't want any noise or vibration from driving the sheets. We were given a vibration limit of 7.5 millimeters per second that we couldn't exceed. And if you look at the actual vibration level in the fourth column, the highest we actually achieved was 4.57, which actually, when it was looked at, we think it was somebody actually kicking the box rather than the rest of the works. But it just shows how low the vibration levels will be from silent and vibration-free piling. It really does what it says on the tin. So a few final thoughts and conclusions. Are sheet piles suitable for what you want? Is the retain height reasonable for sheet piles up to 4.5 meters, or propped or excessive deflections above 4.5 meters? What are the ground conditions? Have you allowed enough room for the piling element? Have you allowed enough room for the pile driving equipment? Is noise and vibration an issue? Does the layout work in whole piles? Engineers have a habit of not designing schemes to allow for whole piles and just assume one can make a lot of specials. That really doesn't happen very often. And have you allowed for deflection and tolerances? Sheet piles is a flexible retaining wall, so you will get deflections when the piles are installed. So in summary, sheet piling is a successful temporary or permanent retaining wall that can be installed in a wide range of site conditions throughout. And installed in a wide range of site conditions through the selection of appropriate equipment and methods. I hope you found that useful. Any questions? Thank you.
Thank you very much, Graham. That was great. We're now going to have 10 or so minutes of questions. So if Jess could join us back. Most of the questions coming through so far actually are for Graham, but let's start off with that question we had earlier on, which said, how is the longitudinal shear transmitted and checked with the joint interlock according to the national annex? So I think that's a question for Jess.
Sorry, would you repeat the question again, please?
How is the longitudinal shear transmitted and checked with the joint interlock according to the national annex?
It's quite a difficult question, to be honest. So I'm going to have to send some information back to you. That's okay.
Okay, we'll answer that by email. let's go to one of the slides Graham showed. Graham,
Hello.
do the 16 to 20 metre sheet piles require anchors? So the sheet piled wall
more than probably. Generally, pile retained heights up to about 4.5 meters would be cantilever. Beyond 4.5 meters, you depending on the site, would tend to be propped or anchored in some way, either single or multiple props.
Okay, thanks. Another question: the 15 meters away from buildings rule of thumb, does it also apply when using silent and vibration-free machines?
No. With silent vibration-free, as tight as you can get to where you need to be. Generally, one needs 750 millimeters from the center line of the sheet pile to install piles, and we've installed piles as close as that. There is a zero piling machine that drives piles perhaps 100 millimeters off of somebody else's wall. But it is available. I think there's one in Europe that's available.
Okay, thank you. Another Graham question. What typical monitoring is carried out to avoid overstressing or damaging the pile? But Jess, feel free to interrupt whenever you want to. But
Thank you, Milton.
Generally, in the UK, it's the drivability of the sheet pile which is the biggest concern, rather than than the pile that's designed for bending. So to be honest, monitoring is not used that extensively in the UK for measuring those sorts of stresses, unless you've got a very sensitive structure or say you're at the top end. It's not something that we do very often, if at all. To be honest, as I say, we normally have a heavier pile to meet the rigors of driving than what's required for design.
Okay, thanks. Now another question about this. What's the rule of thumb for optimum minimum distance from newly installed sheet piles to existing structures in regards compatibility of the pile installation equipment size and the minimum distance?
Well, again, if you've got existing piles I mean, as tight as you can get it, sometimes you'll be driving piles, making the piles slightly longer than what you need in the final condition to drive piles a bit longer, as tight as possible to somebody else's wall, because somebody else's wall might be working in a different direction to your wall, and it's more of the size of the driving equipment, which maybe 750 from the back of the pile.
Thanks. Now, moving on to the vibration level formulae. Can they be used for other types of piling techniques?
I guess it's an empirical formula that's been kicking around for a long time. So we use it as a guide because it measures say distance from the source, the type of source, but actually it's not a fantastically detailed formula if you actually look at what's in there. And to be honest, the best way if you're worried about vibration is to take on actual monitoring whilst you're driving on site, and look at historic data for driving piles in similar ground conditions and similar lengths. The vibration is dependent on ground conditions, the length of pile that you're driving, the equipment you're using, and the length of pile extending out of the ground prior to getting it down to level.
Okay, thanks. What happens if you incur rock obstructions within the ground strata when you're driving? Will the piling system drift away from the intended position? Yes.
You pack up and go home. No, again, this is why we can't stress enough the importance of a good quality site investigation. If you know you've got rocks and boulders in the ground, piles will deflect below ground level, and piling contractors or steel piling contractors will not tend to take on the risk of piles distorting or deflecting below ground level for unforeseen or foreseen rock in the ground. If it's a band of mudstone or siltstone, it may be the piles just stop. And again, if the top of the pile starts turning over and you see deformation in the top of the pile, it probably means that the bottom of the pile's already started being damaged, and the piles can tend to splay out.
Okay, thank you. Now, we've got a question about embodied carbon and what embodied carbon considerations are made in an early involvement contractor two-stage procurement? Oh gosh, not quite sure what that means. Do you know, Graham, what a two-stage procurement means?
No, well, a two-stage procurement, yeah. To be honest, it is something that is just starting to come forward within the industry, and there's a number of manufacturers that are identifying what's being called lower carbon steel, greener steel, or whatever. But and it's more to do with the energy used to produce the steel. And again, whether the steel is produced from raw iron ore or recycled material. It's something that's becoming focused, but genuinely, it's not something that we've seen as a business as a primary thing. Again, sheet piles can be reused multiple times, and the properties doesn't change the fact that they might be 6 months or a year old and been in the ground twice. They're still good quality sheet piles in grade S3, 5, and still can be used. So you're not bringing unlike concrete, you can infinitely recycle it rather than downcycle it.
Yeah.
Maybe I can add on to this actually, Graham. I agree 100% with what you just said. And also with our products, we've got X-Carb products, which are Eco Sheet Pile Plus. So that entails the renewable energy as well as low carbon products, which would be made from 100% scrap material as well. So that would be the one that you'd be looking for to have the low carbon footprint for your projects.
Jess, you mentioned that there were higher strength sheet piles now available in S460. Would that be a way of reducing material and hence a lower carbon solution? And what are the limitations to using these higher strength sheet piles?
So with the higher steel grade, as I mentioned before, you'd be looking at using a smaller sheet pile section, which is, yes, correct. You'd be using less piles, so that less tonnages, so that's lower carbon footprint already. But it doesn't just come down to this one. You also have to look at the manufacturing process and how the steels have been made from the start to the finish of the production process. So with the piles, you can make them through the blast furnace and electric arc furnace route. And with the blast furnace route, you're looking at a lot of carbon intensive making of steel. But when you're looking at it's all because it's using raw materials. So coal, it's the burning of the coal, the burning of the iron ore, and that causes a lot of carbon emission. But when you're looking at the electric arc furnace route of making the steel, you're using not only recycled products, which are the scrap materials, but you're also using electricity as a means of making the steel. So you can start and stop the process at any time, but that reduces your carbon footprint by a lot more. And recently we've also introduced DRI method of making steel. Now with this method of making steel, you're actually using raw material in an electric arc furnace, and it reduces your carbon footprint even further. And then you've also got different other options that you can make the steel with, and using renewable energy from solar power, from wind power, that reduces your carbon footprint even further. So if you're looking at a sheet pile solution, with X-Carb would be the branding for the low carbon sheet piles essentially. And sometimes you've also got carbon capture and storage as well, and carbon capture and utilization. This is something that I'll be working on towards the future as well. And maybe one other thing that I might want to include would be electrolysis. It's a way of making steel, but using oxygen as a byproduct rather than carbon. It's still something that's in our research and development program, and it's ongoing process. But once it's on the market, it would be changing the way of making steel completely. Yeah.
Thank you. Gosh, we're getting stacks and stacks of questions, so we'll carry on a few minutes, and then I think if the speakers don't mind working with me afterwards, we'll circulate a spreadsheet with the answers. So here's a question about extraction. Is this for recovery of financial value or for future structural reuse? How are previously used piles generally accounted for in specs? And is this generally for temporary works, as permanent works require fresh sheets?
Well, there's no reason why used sheet piles can't be used in permanent works. To be fair, when you buy your sheet piles from the manufacturer, you normally get mill test certificates. Now, if you've got a decent quality control system, you can normally control what sheet piles are going in where, and if you've got temporary piles that are going in. I mean, all piles, once they're installed, are used piles by the nature of it, and then one would tend to excavate out for most of the time. But in most of the time in temporary works, the reason you would take the piles out is A, you don't want them in the ground, and B, there is a financial advantage to pull the piles back out. The sheet pile, the model generally is you pay for the sheet piles when they go in, and then when they pull them back out, you then give a credit. So it's a financial incentive to pull the piles out. Quite often on site, town centre, city centre environments, you might have temporary piles going in, but there just isn't the room to get the equipment, the crane, the leader rig, the silent vibration-free machine back into site to pull the piles back out at a later date. We always want to pull piles out. We tell everybody that, and as I say, a good quality used pile, take it back to the yard, you jet wash it down, it looks like a brand new pile, because piles will last 120 years if they're looked after.
Thanks. Jess, what steel subgrades are typically appropriate for permanent steel sheet pile walls?
When it comes to the steel grades, you'd be looking at the higher the steel grade is better with hard driving conditions. And of course, when you're looking at the higher steel grades, you'd be looking at something smaller. So you need to make sure that you're not installing something that's too thin for your ground conditions. But something above S355 to S500 would be what you'd be looking at.
Yes, the question was about the subgrade, the toughness. The Sharpie V-notch toughness.
I think we've got some information on our website for this, but again, this is not something I have in mind just straight away.
Okay, we'll answer that. We'll answer that by a spreadsheet. Now, let's move on to cathodic protection. Is cathodic protection possible to ensure long-term durability, particularly in marine environments? If it is possible, is it used typically, or are other methods preferred, such as sacrificial thickness, coatings, etc.?
My experience is one would tend to use sacrificial thickness rather. Cathodic protection is used, but generally it's more of a passive system in as far as additional thickness of steel that's allowed to erode. As I say, the durability guide that the SCI issued, which number escapes me, 422 was it? That's probably the best one to read through to give the best guidance on that, to be honest.
Yeah.
That's a presentation on its own.
Well, exactly, and we would quite like your feedback on this. This is just a taster webinar. Someone has been asking why we haven't covered tubular bearing piles. So again, if there's enough interest for that, we can certainly do a webinar on that. We're also asked about the ArcelorMittal ALWC resistant grade of steel. Is that still available? Are there any published updates, availability on its effectiveness? I don't know if you want to answer that one now.
Yes, we do have some information on the AMLO core, which is the one that they probably mentioning, which is the ArcelorMittal low corrosion steel grade. I would have covered it because of the time pressure. I don't think it was possible to cover the AMLO core, but yes, we do make them still, and they are used where there's where they are required. So I'm happy to talk about them, send you some information on this, but we've got brochures that would probably be best to have a look through that. If you have a look on our website, there's a lot of information on the AMLO core steel grade.
Thank you. How many times can sheet pile sections be used as temporary piles?
As many times as you like is the answer. Again, it's a function of length over section and the amount of inevitable. There'll be some damage when piles go in and out if one doesn't choose the right pile sections. Generally, and it is a very big generalization, we would perhaps only drive piles perhaps 2 or 3 times before we'll find a permanent home for them. But I mean, the trench, the people that provide hydraulic frames and propping, they'll be using their stuff half a dozen times perhaps before it's written off. As I say, each time the pile comes back, it's cleaned up, it's trimmed up to make sure. But piles generally will get shorter and shorter to a point where it's not economic to be sending out 2 meter long sheets when you've got a trench sheet that could do the same project, do the same job.
Yeah, thank you. I think we'll just have one more question, and this is about steel capping to sheet piles. This seems to be getting more common. I don't know if that's your experience, Graham. Are you able to give a quick overview, pros and cons of this?
Yeah, I mean, generally, there's a bit more of steel capping going on. It's probably because it's cheaper and easier to install than concrete. Generally, again, I'll talk in general terms. A steel capping would normally not be a structural capping for most applications. It's just literally to finish it off and make it look pretty. If you design a steel capping beam that can take some horizontal load or whatever, it might iron out if there's any soft spots in the wall from the local ground variations, but a concrete capping would do that better. Personally, I like a concrete capping. I've got to be honest. I just think it looks neater than a load of rusty steel. But it's horses for courses, and it will probably be cost driven. I mean, on the Fussy Piling website, there's various examples of this sort of stuff going on. If somebody wants to have a look, please do.
Thank you. Thank you to both our speakers today. Brilliant questions. We value your feedback. If there are other topics related to steel piling that would be helpful, let us know what they are. And don't forget to have a look at the Steel Piling Group website and have a look at the downloads there. So thank you again, and goodbye from us all here at SCI.